Hi children, welcome to our class. Last class we have seen that electronic configuration of different elements. In your notebook so many examples are given there for showing that electronic configuration and for showing the structure of the atom. Okay, you can practice it at home. Now we can see valency. The last chapter 3 we have seen valency is the combining capacity of an element. But that time I have mentioned there that we will see valency in more detail in this chapter. So, today we are going to see that topic valency. Actually, how can we define that valency? Suppose for that we can take the element sodium. Sodium, its number of electrons are 11 there, and how do the electrons in that sodium is arranged? The 2, 8, 1. So in K shell 2 electron, L shell 8 electron and M shell 1 electron. So this is the electronic configuration for sodium. So, at that time what is happening during any chemical reaction, these elements are undergoing chemical reaction in order to attain the stability. How can they attain that stability? By making their electronic configuration 8. If that octet configuration, if the outermost shell, that is outside end shell, that outermost shell contains 8 electron, then that configuration is known as octet configuration. If the configuration is octet there, then atom will be stable. Atom will be stable and energy will be minimum. With energy minimum and stability maximum. Okay, energy will be minimum and stability will be maximum. So, if the atom has not attained that 8 electronic configuration, for attaining that 8 electronic configuration, the electrons are undergoing chemical reaction. So, in the case of sodium, it is undergoing chemical reaction in order to attain that 8 electronic configuration in its outermost shell. Okay, outer shell is known as valence shell. Outer shell is also known as valence shell. Okay, and if that sodium, normally the sodium is not stable because it has outermost shell has only 1 electron. There is the no octet configuration, so it is not stable. So, it will participate in chemical reaction in order to gain that stability by making that electronic configuration 8 in its valence shell. How can it make that electronic configuration 8 in its valence shell? Two possibilities are the valence shell is M shell and it contains 1 electron, either by gaining 7 more electron or by losing this 1 electron. If it is losing 1 electron, the previous shell L shell will contain that 8 electrons. So, that is octet and the element will be stable. And if it is gaining 7 more electron, that time also that 7 plus 1 will become 8, so that it will be stable at that time. So, what is happening during the reaction? The elements will try to attain that 8 electronic configuration by gaining or losing electrons. And which is possible for the sodium? Because gaining 7 more electrons require lot of energy there, and that much energy is not there for sodium when it is participating in that chemical reaction. So, for the sodium it is easy to lose that 1 electron which is present inside the atom. Okay, so when sodium is undergoing chemical reaction, it will lose 1 electron from its outer shell, and after participating in chemical reaction, now the electronic configuration is 8, 2, 8. So, the atom will be atom will be very stable. As the octet configuration, the atom will be stable. Okay, but now what happened to the atom? Initially 11 negative charges were there. So, to cancel that 11 negative charges, 11 positive charges also will be there, right? But when that during that reaction, now it has only 10 electron. That means only 10 negative charges are there. But what will happen to the positive charge? Positive charge will remain there as such. It is there in the nucleus, so nothing will happen to that positive charge. It will remain there as such. So, what will be the net charge of this atom there? At that time, positive charge 11 is there and negative charge 10 is only there. So, the net charge of the atom will be positive. So, during the participation of reaction, after losing that 1 electron, now sodium has changed into Na+. Now you understood what is the valency. It has lost that 1 electron when it is undergoing that reaction, and that 1 electron is its valency there. So we can define valency now, that number of electrons gained or lost during the chemical reaction in order to attain that stable 8 electronic configuration. So, valency is the number. Sometimes it will be number of electrons gained. Sometimes it will be number of electrons donated for attaining that 8 electronic configuration, stable configuration for that particular atom. Okay. So, here it has lost, sodium has lost 1 electron there, and its electronic and its valency is 1 there. And it has formed a unipositive ion or monovalent cation there. Okay. Same way, if you are considering the element chlorine, we can consider the other element chlorine there. Chlorine has 17 electrons. Chlorine has 17 electrons in its outermost, total 17 electrons are there. So, how will we arrange that electrons in chlorine? So, we can show the electronic configuration as 2, 8, 7, total 17. So, outermost shell contain that 7 electron. How can it gain that octet configuration, attain that octet configuration? Either by gaining 1 more electron, by adding 1 more electron to the 7, it will become 8, or by losing that 7 electron present in the outer shell. Gaining 1 or losing 7, which is possible for them, for that chlorine? Yes, it is easy for chlorine to gain 1 more electron. Okay, so at that time when it is undergoing chemical reaction, it will gain 1 more electron and will become as 288, and the chlorine now, that chlorine has 1 more electron. Totally 17 proton, 17 plus and 17 minus were there, but now 1 more electron has added there. So, now the electron is 18 there. So, the net charge will be -1. Okay. So, how many electronic gain during that reaction to attain the octet configuration? 1 electron. So, the valency of chlorine is again 1. Okay. So, we have seen in the case of sodium also valency 1, and chlorine is also valency 1, but sodium, after gaining that octet configuration, sodium has changed it to Na+ ion. Now the atom is not existing as atom, now it has changed into ion. So, cations, and here it is anion. So, during that chemical reaction, cations and anions are produced there. Okay. So, once again we can define that valency. Valency is the number of electrons gained or lost during a particular chemical reaction in order to attain the stable electronic configuration, that is 8. Okay. And now we can see when the sodium and chlorine is reacting there together, sodium and chlorine. At that time, sodium will donate 1 electron to chlorine and chlorine will gain that electron, so that sodium chloride formation Na plus and Cl minus will be formed there, and as they are opposite in charge, they will have a strong force of attraction, and that is how that sodium chloride is formed. Okay. So, we have seen the valency is the number of electrons gained or lost during a chemical reaction to attain the stable octet configuration, and that electrons shell that which is present outside, that is known as outermost shell or valence shell, and the electron present in the valence shell is known as valence electron. Electron in valence shell, electron in valence shell. Electron in valence shell is known as valence electrons. Valence electrons. Okay. And now we can see the valency and valence electron. In case of chlorine, what is the valency? We have seen that valency as 1. But what is the electronic configuration for chlorine? It is 2, 8, 7. So, what is the number of valence electrons? Valence electrons are the electrons in valence shell. Which is the valence shell here? This is the valence shell, and there are 7 electrons are there. So, the valence shell contains 7 electrons. So, we can say that valency is 1 and that number of valence electrons is 7 present there in chlorine. So, the valency and valence electrons are different there. But in case of sodium, the valency and valence electrons are the same. In case of sodium, 2, 8, 1. So, during reaction, it will lose that 1 electron, 2, 8 will be produced there. So, valency is 1 here, and how many electrons are present there before that reaction? In that valence shell, that is 1. So, here the valency and valence electrons are the same. Here the valency and valence electrons are different. Here it is different but here it is same. So, in some cases valency and valence electrons will be the same, whereas in some other cases valency and valence electrons are different. The valency is the number of electrons gained or lost during a particular chemical reaction, and valence electrons are the number of electrons present in the outermost shell of an element. Hope you understood this much about the valency and valence electrons. So, you will get questions to calculate the valency of a particular element, like so you will be getting questions, and hope you understood this much. Thank you.